Hello guys, welcome to my channel Code by Vansh, and today we are going to solve the question combination sum part 2. So in this question we have actually given the collection of candidate and a number target. Find all unique combination in candidate where candidate I sum to target. Each number in candidate may only be used once in the combination. Okay. So in the previous question we have actually seen that if our two, let's say 2, 3, 7, 6, and our target is actually 7, so I can take 2 any number of time. Okay, so I can take 2 any number of time. I don't have any restrictions. I can take it ultimately, okay, unlimited amount of time. But here it is actually given that I have to keep in mind that I can only take 2 one time. Okay, so this is the only thing that is different in actually this question. So how we are actually going to solve it? So first of all, what we are going to do, this is actually an unsorted array. We are going to sort it. Okay, we are actually going to sort it. So after sorting, let's say we are sorting. Okay, so after sorting it will become 1 1 2 1 1 2, then it will be 5, then it will be 6, then it will be 7, then it will be 10. This is the thing. Now they are saying that I can take any element only one time. Okay, so how we are going to place our logic? If it is one time, okay, first we take 1. So this I will take 1, or I will not take 1. If I take 1, okay, so here actually what is actually going on? Now let's move to the recursion tree actually. Now let's move to the recursion. This is the thing. If I have 1 1 1 2 and 2, okay, so here I have so many options. Either I can take 0th, either I can take first, second, third, any number. Okay, but what I have to keep in mind, that it will not be duplicate, because here I can't take first and second index for 0 1 2 3 4. I can't take first and second index because they are 1. Okay, because they are 1, and I can't take 3 and 4 index simultaneously. As here you can see, I can't take third and fourth index simultaneously. If I take third, I can't take fourth. Okay, so how we are going to actually solve this question? If I take index at 0th, then my function will actually move on. My function will actually go to another index. First it will be at 0, it will go to f plus I plus 1. Okay, it will become I plus 1. Okay, and the sum will actually become, okay, now here the target is actually 4. So what will my target will become? 4 minus 1, because I am taking 1, and at my this will look like this. Okay, I plus 1, because it will be at first it is 0 place, and then I am just going for 0 plus 1, so it will become f1 3 1. I can actually take this position, and then there are actually positions at every step. Either I can take 0th step, 4, and so on. Okay, so at first index what I am going to do, I am just going to take first, because I can take first because I am on first index, so that's why I am taking first. Okay, so you will say I am taking 1 2 times. I am taking 1 2 times, but this is not the case actually. Here they have different indexes. First I am at this index, so while I am at this index, I can't take any other ones. Okay, now this index is over. I am at a new index. I am at 1th index. So when I am at 1th index, I can't take 2th 1. I can take 1th 1. So this is the thing I have to keep in mind. Okay, this is the thing that I have to keep in mind. So after this, what I am going to do, I am just going to take second and third index, and I will just move forward. So this is my actually pseudocode. This is actually the pseudocode for this index. If my array is actually greater than target, then actually I am going to just break it out, because why I am going beyond this condition? Okay, I will just create a loop for index 1 to n minus 1, obviously. And if I am taking index, what I am going to do, I am just going to add it into my data structure. I will increase the pointer or the function, I will decrease it, and for the backtracking I will just remove it. Okay, so these are the just 2-3 steps that I am actually doing here in this question. Now let's move to the coding part, and in the coding part it will be much more clear. Okay, so first I am sorting, as I told you, I am sorting, then I am just going to give it to the function, and this is basically the test case. If t is actually 0, this means it is at the end, and if it is not at the end, I am just creating a loop, because if I am at 0th index, I have choices. Like I will take 0th index, I will take 1 index, 2 index, 3 index, 4 index, like this. Okay, if my index is actually greater than I, because when I am at 0th index, when I am at 1th index, okay, I am at 1th index, so actually my index, okay, actually my index is actually greater than, because 1 is actually greater than 0, so that's why it is actually greater than 0. And if it is actually greater than 0 and it is same, like 1 is actually equal to 1, so that's why I am not going to take it, I will just continue it, because in the question itself it is given that I can't use duplicates. Okay, so while I am at this position, I can't take duplicate. And if it is less than v, then actually I am just going to break it out from the code. So these are the 2 steps I have to keep in mind, and at the end I am just pushing it into the vector, and while I am pushing it, I am just making my recursion call. As I have told you, if this is my function, I will just add it. There are 3 steps. First step is actually adding it, second step is actually calling my function, and third step is actually backtracking it. Okay, so backtracking part is really important, because if it is at the base condition, and at the base condition it has to move upwards, because there are 2 parts, one is left part and one is right part. So in order to execute the right part, I have to backtrack it, because if I don't pop it, then it will just make the code errors. Okay, so this is the coding part. Make sure you like the video. Thank you for watching.